Next question is related to Nash equilibrium. The question is the sum of payoffs to the players in the Nash equilibrium of the following simultaneous game is. We are being given the payoff matrix for two players. We have two players, player X and player Y, and their strategies are cooperate or not to cooperate. And similarly for player Y, we have cooperate or not to cooperate. Payoffs are being given in the cells. The first element in each cell denotes the payoff for player X, and the second element in each cell denotes the payoff for player Y. Or let me write it here with another color. So we have here 40, here we have 30, here we have 20. Okay, so the black number denotes the payoff for player X when she or he chooses a specific strategy, and similarly the red ones are the payoffs for player Y when she or he chooses a specific strategy. We need to find out the Nash equilibrium in this case, and we need to add the payoffs of the players. So let's first find out the Nash equilibrium. By Nash equilibrium, what we mean, Nash equilibrium is a situation in which a player chooses his best strategy given the other person or player has also chosen his or her best strategy. And why does this happen in this question? So how do we solve? Let me explain that very stuff here. So let us suppose player X cooperates. Okay, so when player X cooperates, player Y has two choices, either to cooperate or not to cooperate. Cooperate gives him 50 as payoff, not to cooperate gives him 30 as payoff. Obviously 50 is greater than 30, so let us underline this. Likewise, let us see when player X chooses to not to cooperate. Again, player Y has two options, either to cooperate or not to cooperate. Cooperate gives him 40 as payoff, not to cooperate gives him 20. Obviously 40 is greater than 20. Since we assume that the players are rational, they will choose higher payoff. Now let us see from the perspective of player X when player Y has chosen to cooperate. When player Y chooses to cooperate, again player X has two options, either to cooperate or not to cooperate. Cooperate gives him 50 as payoff, not to cooperate as 30. Obviously 50 is greater than 30, he will choose to cooperate. Symmetrically, when player Y chooses not to cooperate, again player X has two options, either to cooperate or not to cooperate. So cooperate gives him 40, which is greater than 20, so she or he will choose 40. Now, why does the Nash equilibrium exist in this question? When both the numbers in a particular cell are underlined or encircled or whatever you call, that will give us the Nash equilibrium. Nash equilibrium cannot be Pareto-optimal at times, okay? But it is the best strategy for both the players to cooperate in this simultaneous game. Now we need to find out the sum of the payoffs. So sum of the payoffs will be at Nash equilibrium, which is 50 plus 50, which is equal to 100 in this case.